Okay, so how does a city turn garbage into infrastructure? You put a bag of trash out on the curb, a truck picks it up and drives it to a building on the edge of town. Inside that building, the garbage burns. The heat boils water, the steam spins a turbine, electricity goes into the grid, hot water flows through pipes under the streets into people's radiators, and the ash that's left over gets processed and laid down to build the road that truck drives on. Trash in, power and roads out. Sounds like a machine that turns garbage into treasure. It is not that machine. It is something stranger, because here's the first thing nobody tells you when they picture this process. The city pays the plant to take the garbage. Every ton of trash that rolls through that gate arrives with a fee attached to it. The plant's real product isn't electricity and it isn't road material. The plant's real product is disappearance. And the plant's biggest fear isn't running out of customers. It's running out of garbage. By the end of this, you'll understand what a city is really buying when it builds one of these, and why the one thing the machine needs most is the one thing the city was trying to get rid of. That last line sounds backwards, so let's back up and look at the money first, because the money is where this whole story stops making sense and starts making sense at the same time. Take the most famous version of this machine on Earth, a plant in Copenhagen called Amagerbaki, better known as Copenhill, the one with the ski slope on the roof. It's operated by a company called ARK, and ARK is owned by 5 Danish municipalities: Copenhagen, Frederiksberg, HV Dovre, Tardby, and Dragør. Together they serve roughly 645,000 residents and 68,000 businesses. And the first thing you need to understand about the plant is that the money doesn't come from the power. It comes from the garbage. Every ton of waste that arrives at the gate costs someone money, in the neighborhood of 60 euros a ton. And the arrival is a ritual. Trucks line up at the weigh scale. Every load is weighed on the spot. The fee is calculated on the spot. The city's garbage is literally a metered commodity, and the meter never stops running. Let's do the math on what that actually means. The plant is permitted to take around 560,000 tons a year. At 60 euros a ton, that's well over 30 million euros a year, just at the weigh scale. And then the taxman steps in, because roughly 60% of that gate fee goes straight to the Danish national government as a tax on disposal. The plant keeps the rest, so even the fee is partly a tax on throwing things away, designed to make burying trash more expensive than burning it. Read that again. That gate fee is not a profit margin, it covers the loan, the staff, the maintenance, the tax, and the ash. It's the price of making the problem disappear. The point is the direction of the money. You might assume the city built this plant to generate cheap electricity. It didn't. The electricity is the byproduct. The city pays the plant to make its problem disappear. And the plant sells the leftover energy and the leftover ash to help cover the bill. The disposal is the business. Everything else is the discount. That's the frame that explains the entire structure, so let's hold on to it and look at what it costs to build in the first place. A modern waste-to-energy plant at this scale costs a genuinely absurd amount of money. Copenhill itself came in at somewhere around 500 million euros. And here's the part that makes it possible. It wasn't financed by a bank chasing profit, it was financed through KommuneKredit, an institution owned by Danish municipalities, essentially the cities lending to each other at low rates, with the owner municipalities guaranteeing the loan and a financial plan built to run the plant for roughly 30 years, which means 5 mayors signed their names to a promise. Their taxpayers will keep this machine alive for 3 decades, come what may. If you're wondering how a city government gets away with borrowing that kind of money, the answer is the same reason the whole thing works at all. The loan is cheap, the guarantee is the city itself, and the repayment is built into the flow of garbage that was going to show up anyway. Let that land for a moment. The machine isn't just a building, it's a promise. And the promise has a very specific shape, because a plant like this is not a factory you can switch on and off. The building on that site isn't the first one. There's been a waste-to-energy facility there since the 1970s, and that history is part of the economics. When the owners planned the new plant, they didn't start from scratch. They built on the same ground, deliberately, so they could reuse the existing connections to the city's power and heat networks. New furnace, old pipes. That one decision saved years of permits and millions of euros. And it says a lot about how this business actually thinks. The cheapest infrastructure is the infrastructure that already exists. The garbage was already coming to this address. The heat was already leaving it. The new machine just did the same job, louder and bigger. To understand why that matters, you have to stand inside one of these buildings for a minute. Not the pretty rooftop, the guts. A waste-to-energy plant is basically a giant oven wrapped in plumbing. Garbage trucks back up to a tipping hall and dump everything into a bunker the size of a small parking garage. A crane claw the size of a car swings overhead, grabs a load of trash and drops it down a chute into the furnace. The heat turns water into steam, the steam hits a turbine, and the turbine spins a generator. What comes out the other end is electricity, hot water, and a pile of ash. That's the whole process, nothing else. Simple enough to draw on a napkin. The complication isn't the chemistry. The complication is that this particular oven refuses to be turned off. A furnace full of burning waste is not a light switch. The plant is designed to run 24 hours a day, 365 days a year. It has 2 furnace lines, and each one burns somewhere between 25 and 35 tons of waste every hour. The crane claw that feeds the furnaces never really stops moving. On a busy year, the plant processes well over 500,000 tons of waste, enough to supply heat to something like 90,000 apartments and electricity to around 80,000 households. That's the scale we're talking about. And there's always someone in the control room watching the screens. Christmas morning, a shift operator is watching the furnace. The furnace doesn't care about holidays, neither does the schedule. The shifts don't stop, and the people in that control room have their own version of the calendar. It isn't the holidays, it's the tonnage forecast, the number that tells them how much waste is expected through the gate next month, and the month after that, and the month after that. Because everyone in that room knows the same thing. This machine eats a certain amount every single hour, and if the gate goes quiet, the furnace still has to burn. When the forecast slides, the mood slides with it. Not because anyone is worried about the environment, because everyone knows what a quiet gate means. Here's what the scale hides. Stopping is expensive. Cooling a furnace down, cleaning it out, and firing it back up is a costly and damaging process. A plant like this is engineered to keep burning. The debt doesn't take a day off. The maintenance schedule doesn't take a day off. The machine doesn't take a day off. Even the routine maintenance is a chess game. Furnace linings crack, screens clog. The turbine gets serviced on a schedule measured in hours, not days. Every planned shutdown is a bill the city pays twice. Once for the work, and once for the garbage that had to be stored or sent somewhere else while the furnace was cold. So now you know the first rule of the business. The furnace must never stop. Which brings us to the part that flips the entire story. Because a plant that must never stop needs a guaranteed supply of fuel, and its fuel is your garbage. And this is where the economics get genuinely strange, because the plant in Copenhagen was built with more appetite than the city could feed. Here's what that rhythm looks like from the city side. The trucks start arriving before dawn. The weigh scale clicks, the bunker fills. All morning the claw feeds the furnace, and all afternoon the pipes carry heat out to the neighborhoods. In the evening the apartments are warm, and nobody in them thinks about the machine that made it possible. That's the arrangement. The city gets rid of its garbage, the buildings get heat, the plant gets its fuel, and everyone goes to bed. And inside the building, there are people whose whole job is to keep that rhythm going. Truck drivers, crane operators, control room engineers, mechanics who fix what the furnace breaks. Some of them have spent decades at the same site, watching 3 generations of machine do the same job. The only problem is the math underneath the whole arrangement. The machine needs more fuel than the city produces. During the design phase, the capacity was actually increased from 430,000 tons a year to 560,000 tons a year. That's the number the environmental permit allows, and it's a big number, and there's a second part to that number. The permit is not a floor, it's a ceiling. The plant can't simply burn more to fix a bad year, because the permit caps it at that figure. The only direction the tonnage can move is down, and down is the dangerous direction. Put that number in human terms. 560,000 tons a year is about 1,500 tons a day. Call it 150 garbage trucks at the gate, every single day, every single year, for the life of the loan. But here's the problem. The 5 owner cities don't produce that much garbage. Not even close. So the machine is hungrier than the city. The risk isn't too much trash, the risk is too little. Keep this in mind, because it's the single most important fact about this industry, and almost nobody thinks about it when they look at the pretty pictures of the ski slope. Every other part of this story flows from that one awkward detail. A machine built to eat more garbage than its own owners can feed it. So where does the extra fuel come from? Other places, other municipalities. And when the winter demand is high, other countries. This is the part of the story that sounds made up and isn't. Across Northern Europe, countries built more incineration capacity than their own garbage could supply. At the same time, other countries made burying their trash so expensive that it became cheaper to ship it across the sea and burn it somewhere else. Baled waste, stacked in containers, loaded onto ships, sailing toward a furnace. Countries shipping their garbage to each other because the numbers said it made sense. If that sounds like a trivia detail, it isn't. It's the difference between a furnace running at full load and a furnace running below capacity, and in this business, capacity that isn't used is money that isn't earned. Think about what that means for a second. A city's waste stream stopped being a local problem and became a commodity with a price and a shipping route. And here's the part that tells you how real the hunger is. The owners of the Copenhagen plant had restricted waste imports for years. The 5 municipalities had said, no, we don't want our green machine burning other people's trash. Then the tonnage forecasts started sliding. The furnaces were running short of fuel, and the mayors changed their minds. They approved a temporary waiver to import more waste from abroad through the end of 2025, just to keep the furnaces running. They admitted the extra imports would raise emissions, and they did it anyway because the alternatives were worse: less recycling, worse finances, or a furnace that couldn't do the job it was built for. Let that land. 5 elected officials signed off on burning more imported trash and more carbon on purpose because the machine demanded it. That's not an accident. That's the dependency made visible. And now we get to the trap hiding inside the whole green story. Because a plant that needs your garbage has a very specific enemy, and the enemy is recycling. Every ton of waste that gets sorted, recycled, composted, or avoided is a ton of fuel the furnace never gets. The greener the city gets, the hungrier the machine becomes. The city's environmental success is the plant's structural risk, and that tension isn't hypothetical. It's the pressure underneath the entire industry. The thing operators worry about when they look at the tonnage forecast for next year and the year after. The machine was financed assuming a steady stream of garbage, and the city is now trying to make that stream smaller on purpose. Same government, same pile of trash. 2 completely opposite goals. That's a real conflict. It's just not a conflict anyone puts on the tourism poster. The recycling campaign and the incinerator are aimed at the same pile of garbage, from opposite directions, and one of them has to lose. The tourism poster, by the way, is real, and it's the most telling detail in the whole story. The plant in Copenhagen has a ski slope on the roof. People literally ski down the side of the building while the furnace burns beneath them. And here's the part that tells you how the green image gets manufactured. The ski slope cost around 11 million euros, and Danish law actually forbade using waste money or energy money to pay for it. So it was funded through a separate foundation, roughly 49% private donations and 51% loans from the owner municipalities. The city legally had to keep the recreation area off the books of the waste business, because the recreation area isn't a waste business, it's a marketing department. And this is the detail worth holding onto, because the slope is the visible sign of success that tells you the least about whether the machine underneath it is actually doing its job. The slope isn't the business, it's the poster. The skiers up there see the city spread out below them, they don't see the furnace, and they're not supposed to. And that's before you even get to the label the whole project wears: renewable energy. The truth is more careful. Only the plant-derived part of the garbage, roughly half of what goes in, counts as renewable. The other half is plastic and fossil material, and burning it still releases fossil carbon. The plant is genuinely better than burying the waste in a landfill. It is not carbon neutral, and it is not a free environmental win. It's a carefully engineered machine that makes a bad thing less bad, while desperately needing that bad thing to keep showing up. So far, the whole thing sounds like a machine that turns trash into treasure while quietly praying the trash never stops. Now here's the part where the title finally pays off, because after all that burning, something does get left behind, and that something really does become infrastructure. When a ton of waste burns, roughly 1/6 to 1/5 of its mass comes out the bottom as ash. That ash used to be treated as waste itself. But modern plants don't just dump it. The ash gets screened. Magnets pull out the scrap metal, and even the leftover isn't leftover until it's been picked through twice. The mineral material that remains gets processed into a cement-like product that can be used in construction. In Europe, a lot of that processed bottom ash goes into road building, spread out, compacted, and rolled into the base layer that a new road sits on. Let that land. The garbage you throw away can end up literally underneath the road you drive on. The title of this video isn't a metaphor, it's a construction detail. The trash becomes the road, so the machine does work. Trash goes in, power comes out, heat comes out, roads come out. So why doesn't every city on Earth build one of these and solve its garbage problem forever? The honest answer is that this machine only works under a very specific set of conditions, and Copenhagen happens to have almost all of them at once. Most cities don't. They have sprawl, cheap land, no heat network, and a landfill that's still cheaper than any alternative. For them, this whole story is a story about someone else's city. So why does a city like Copenhagen go through all of this in the first place? Because the alternative was running out. Land is scarce. Burying trash is taxed and restricted. A city that buries its garbage pays that bill every year, forever, and still ends up with a hole in the ground that has to close someday. The plant is the answer to a question the city already had. The question was never whether to get rid of the garbage. It was how. First, you need density. A city packed tight enough that garbage is a genuine logistics problem, and land is expensive enough that burying it is a genuine cost. Second, and this is the big one, you need a district heating network. Miles of pipes running under the city, carrying hot water into apartments and offices. Copenhill doesn't just sell electricity, it sells heat, and heat is what keeps the business alive year-round. And here's a counterintuitive detail about that heat. Per unit of energy, electricity is worth about twice as much as heat, but heat is sold in volume, all year round, and a plant that sells heat can run at nearly full load even when nobody needs the extra electricity. The heat isn't the glamorous product, it's the dependable one. A plant like this in a sprawling city with cheap land and no heat network is just an expensive way to make electricity that nobody needs at a high price. Third, you need expensive alternatives. The model works because dumping garbage in the ground is heavily taxed and restricted. Where landfill is cheap, the entire business case collapses. And fourth, you need municipal credit, a government willing to guarantee 500 million euros of debt for 30 years. Take away any one of those conditions and the math falls apart. That's why this is a story about one specific machine, not a template for the whole world. Here's what a good year looks like for this machine, and here's what a bad one looks like. In a good year, the gate is busy, the furnaces run hot, the heat customers pay, the loan gets serviced, and the city barely notices the plant exists. In a bad year, the gate is quiet, tonnage slides, the furnace still burns, because it has to, but it burns below capacity, and every empty tonne is a tonne of missing revenue. The heat customers don't care, they just pay. And the loan doesn't care either, it comes due either way. The difference between those 2 years isn't measured in drama, it's measured in quiet, compounding losses on a 30-year schedule. Neither scenario is exotic. Both happen constantly across this industry, sometimes to the same machine a decade apart. That's the whole difference between the poster and the balance sheet. So here's the honest answer to the title. Does turning garbage into infrastructure actually work? As an energy system, it's marginal. The electricity is a nice bonus, but nobody builds a 500 million euro furnace to make electricity. As a disposal system with a heat business bolted on, it works. It works because it turns a permanent problem into a permanent flow, and it has a customer for everything that comes out the other side. This is not a trick, and it is not a miracle. It's a very specific machine doing a very specific job under very specific conditions. But those conditions are exactly what makes it fragile, because a machine that must never stop, financed on 30 years of guaranteed debt, depends on two things that must keep flowing forever. The garbage has to keep coming enough tons every single year to feed the furnace and service the loan. And the heat customers have to keep paying, the apartments and offices connected to those pipes under the street. Everything else, the power, the roads, the ski slope, is downstream of those two flows. If either one slows down, the machine doesn't break dramatically. It just starts losing money quietly, 1 year at a time, on a schedule the 5 mayors already signed for. Which brings us back to the opening and to what the city was really buying when it wrote that check. Look at this plant from the outside and it looks like a solution. A machine that takes the thing you don't want and turns it into the things you do want. But that's not really what it is. The city didn't buy a way to make its garbage disappear. It bought a promise that the garbage would keep showing up. The machine's most important input is the one thing the city was trying to get rid of, and the city signed a contract to feed it for 30 years. The garbage isn't the waste product of this system, it's the fuel. And the fuel is the obligation. Turn it around and say it plainly. The city isn't turning garbage into treasure. It's turning a permanent problem into a permanent bill, and it's calling the bill a solution. The roads get built, the heat flows, the skiers ride down the roof. Tomorrow morning, the same trucks will be back at the gate, same loads, same fee, same furnace. And underneath all of it sits the real transaction, the one nobody photographs, a city paying itself to make its own problem disappear every single day, for as long as the furnace keeps burning. And the furnace never stops.